Here I would like to show the implementation of vectorized Newton-Raphson method to solve the system of nonlinear equations. I consider a simple system in which one equation is of circle and the other equation represents a parabola. And to our belief, they intersect at 2 points. And a form which is in conformance with the function style is here, that we represent x1 for x and x2 for y, and we have to deal that in Python with 0 and 1. So I start programming in the inspective way. So import numpy as np. I require this library for the calculation of inverse and for matrix vector multiplication. Okay. So I define a function, capital F. So for this function, I define the number of elements. So it should be consistent with the size of x, where now the elements of x will be recognized as with the indices 0, 1, 2, 3 up to n minus 1. So I define now f values to be returned as numpy zeros, and there must be n zeros of type float. And now f of 0 from the first equation, so it is x2 squared. So I write here x1 squared. So this is for square in Python, minus 4 times x1, which is x0. Okay. Then f of 1, the second element in the function, it will come from x0 squared plus x1 squared minus 1. And to return, I write return f float. Oh, so I missed the ending apostrophe. It must be here. Okay, this is fine. This is fine. I can check for values. Like if I define x as 0, 1, x as numpy, okay. At the top, x is equal to numpy array, and I can define 0 and 1 value. Okay, let's take this simple one. 0, 0. And now if I define f of x, so I get reasonable values. Now we require another matrix, Jacobi matrix. Yes, this is the Jacobi matrix that I required for this problem. And then I require its inverse. So I define a matrix, and I define for J inverse. And this will be for a vector x. And again, I define n equal to size numpy, size of x. And for a matrix, I define a matrix numpy zeros n by n, and the values should be real values. So J matrix, this is preparation of J matrix. Okay. Then the first element of J matrix, it is 0, 0, J 0, 0. So this should be equal to -4, right? Something I made as a mistake in Excel demonstration. So then the second element, J, in the same row and in the first column, this should be 2 times x2. So 2 times x2, which should be in Python x1. Then J of 1, 0, right? This is again 2 times x1, 2 times x0, right? x1 is to be replaced by x1. So x0, okay. Then J of 1, 1, the last entry, it is 2 times x2, which is x1 in Python. So this is the matrix calculated. I then require the inverse of it. So I define J, I, and V. So it is numpy, and from the linear algebra library, there is a function inverse of J, and that's it. And return J, I, and V. Okay, that's fine. That's okay. Now the algorithm. We have defined the function, array function, and we have defined the Jacobi inverse matrix. So now we are ready to do the iterations. Okay. So the first step, start with some old approximation. So I define x old numpy array. So you may notice the consistency and similarity in the variable definition with the single variable problem. So I start from 0, 1. X old has been defined. Now, x new value is equal to x old minus J inverse. So I define J inverse of x old times f of x old. So since these are matrices, therefore I have to use the proper routine, proper function to get that product. So I write numpy matrix multiplication. Well, this function is strange that it is directly available from numpy address. The other functions are available from numpy.linear algebra library and that one. So sometimes I make a mistake, and then f of x old. I hope it will not crash. Okay. This was missing. So Python allowed me to compensate for the discrepancy in the next line. It continued that line. So x new has been calculated. I can see x new value. Then there comes the error definition. So let's define the error. Error should be from some standard norm. So I use the second order norm numpy from linear algebra dot norm. So it is second order norm of x new minus x old, right? So 3 steps. Once you have the function, array function, the Jacobi function, then start with x old, calculate x new, calculate error. So error is of float type 0.24. The next step is to update the initial approximation. So these 3 or 4 lines should be in a loop where you can ask computer to make a check on the convergence of the solutions. So now I write x old equal to x new. Then with the up arrow key, I can get to the command x old. So now x old is going to generate x new, right? I skip the viewing of x new. I just directly compute error. and then error should be compared with the tolerance level. So earlier error was 0.25 and now the error is 0.031. So it is on the track of convergence, right? So I have successfully programmed in Python to show the vital steps of Newton-Raphson method implementation. So that's it. That's it. So you can build on it to find the solutions of a general n by n nonlinear system of equations. Take a deep breath. It calms the mind. It calms the mind. Just final comments. With this, we have come to the conclusion of system of nonlinear equations. There is another example. There is just one point I would like to mention here. When you consider the general systems, so when you come across a 3x3 nonlinear system, so it shows you the interaction and intersection of surfaces, right? But beyond that, the geometrical interpretation and visualization is lost. However, mathematics is there to help you out. You have to consistently define the things. The Jacobi matrix structure will be expanded, and Jacobi was appreciated in his country, in probably Germany. Therefore, a stamp was dedicated to his name. And there are contributions of Cauchy as well. So maybe Jacobi has popularized the concept of Cauchy, the way I have popularized the concepts of Cauchy and Jacobi, right? And help my students to discover, rediscover, and believe even there is another witness. Okay, if you see the algorithm structure, there is a value in this one. Professor Burden has discussed this topic in 10th chapter, after discussing the linear algebra. In linear algebra, the inverse calculation is really tricky, even though the procedure is known. However, when it comes to computer to calculate inverses, there are problems, right? The inventor of MATLAB, Dr. Cleve Barry Moller, he wrote a paper in which he said there are 20 pseudo ways to calculate inverse of a matrix. Right? 20 ways. Right? There is a famous algorithm with the recent Nobel laureate name, Roger Penrose. So Roger Penrose, Morse and Penrose pseudo inverse method. I think that is also implemented in Python. When the matrices are sparse, like you have only the elements near the diagonal entries and the rest are zero, so you have to find special ways to calculate the inverse, which means you have to find special way to calculate solution of AX equal to B. यहाँ पर ये लाइन मैंने लगा दी कि प्रोफेसर साहब लिखते हैं सॉल्व n क्रॉस n लीनियर सिस्टम JXY, ये नहीं कहते कि ये इनवर्स लिखते हैं, क्योंकि इनवर्स लिखने की बात जो है वो 2/2 3/3 तक ही जाती है, राइट? उसके अलावा फिर इसे सॉल्व करने के लिए आपको कुछ और डायरेक्ट मेथड्स एंड आल्सो द इनडायरेक्ट मेथड्स ऑफ डूइंग दिस हैव टू लर्न एंड हैव टू इंप्लीमेंट, राइट? तो ये यूं लिख दिया जाता है कि यहाँ से करें गॉस एलिमिनेशन से करें, गॉस जॉर्डन से करें, LU फैक्टराइजेशन से करें, QR फैक्टराइजेशन से करें, या इसको जैकोबी मेथड से सॉल्व करें, या इसे गॉस सीडल से सॉल्व करें, या SOR मेथड से सॉल्व करें. ये सारा आपको पढ़ाएंगे डॉक्टर मोहम्मद रिजवान अली साहब, राइट? कि यहाँ से आगे कैसे जाते हैं वो सिलेक्शन वो करेंगे कि आपको क्या पढ़ाना है. अभी डायरेक्टली मैंने इनवर्स फंक्शन को भी यूज कर, राइट? तो ये बात इंपॉर्टेंट है कि इस चीज को देखने की जरूरत है. आज हमने खुद से देखा, even though there was a problem that inverse calculation of a matrix इट्स ए सेंसिटिव कैलकुलेशन, इट मे क्रैश। सिंगल वेरिएबल न्यूटन रैप्सन मेथड का भी प्रॉब्लम यही था कि व्हेन द एफ प्राइम ऑफ एक्स comes out to be equal to 0 then it is going to crash। इसका भी इसी तरह का है कि इनवर्स क्रैश हो सकता है। तो अगर आप उसको बचा लें, उसके लिए कुछ मेथड्स हैं लोगों ने लिखे हैं, दे आर ऑल बेस्ड ऑन दीज मेथड्स। अब इससे आगे की चीज जो है नॉन लीनियर इक्वेशंस के लिए या ऑप्टिमाइजेशन के प्रॉब्लम के लिए, लीस्ट स्क्वायर मेथड्स के लिए, वो सारी की सारी इन्हीं मेथड्स से ही इवॉल्व हुई। उसको पढ़ाने के लिए हमारे पास कोर्स में टाइम नहीं है और हौसला भी नहीं। टाइम हमारे पास नहीं है, आपकी तरफ हौसला नहीं है, तो सोल्यूशन यही है कि हम कुछ और टॉपिक्स की तरफ चले जाएं। तो लीनियर अलजेब्रा के टॉपिक्स आप पढ़ेंगे, उसके अलावा हम जो पढ़ेंगे डिफरेंशियल इक्वेशंस। डिफरेंशियल इक्वेशन का सोल्यूशन, उसको पढ़ने में एक मजे की बात कि हम कोई नई चीज नहीं पढ़ेंगे। हमने जो चीजें पहले पढ़ी हैं हम उसकी एज एन एप्लीकेशन पढ़ेंगे, डिफरेंशिएशन और इंटीग्रेशन की एक एप्लीकेशन के तौर पे उसे पढ़ लेंगे। मेरी बात को ध्यान से ही सुनिएगा और इसे कॉन्टेक्स्ट में ही इंटरप्रेट कीजिएगा। एक दफा